Hello, good evening. This is Professor Khan, and this is Energy System Technologies, EST-204. And this week we're talking about windows and doors. I'm not sure which chapter is this in your book because we have different versions, but I'm sure there is a dedicated chapter in the residential energy book about windows and doors. So let's see what we have. So we would like to know about how to identify windows characteristics, what makes a window, what are the components, what are the parts, how they differ, and hopefully they will add some information to your knowledge. Uh, Again, structure and components. What are the features? What are different types of windows? How do we counteract the windows problems that, again, I did say before that the windows are a problem for HVAC technicians because we lose and gain a lot of heat from windows and doors. List available options for window treatment. That's again, how do we counteract windows and doors issues. Door types, possible air leakage areas. Okay, windows. Again, to repeat myself, what are the two major heat loss in a house? From last week, I got so many various answers, and they are two: infiltration and transmission. And they are both present in Windows. So Windows have both infiltration and both transmission. So Windows again are a big issue when it comes to trying to limit heat loss. Windows have three main functions. They provide us with a nice, beautiful view. They provide also natural light, which is again, it's an advantage, it's a plus. They provide ventilation. You always want to open the window to get some nice flood of air coming in or to vent the house. But it's an ongoing battle because again, we are losing, as you can see here, we're losing heat. So we're losing a lot of stuff. It's an issue, a lot of negative factor when it comes to HVAC, but also it's very important. Nobody wants a house with no view. Nobody wants a house with no windows. And again, the more windows, the more attractive the house is. But again, that will mean a lot for somebody who knows something about HVAC. So what type of windows are there and how much heat I'm going to be gaining or losing because of these windows. Uh, Windows are expensive. I mean, the last I checked, it costs around like between $500 to $1,000 to change one window. So keep that in mind when you're trying to buy an old house with old windows. There's going to be an additional cost for you to retrofit these windows. So it's very expensive, but it's well worth the money to invest in before you change your heating and cooling system. Doors are not as bad because again, they're usually made out of solid material. They provide enter and exit. They can double as a window for view and light if you have a glass or French door. But again, then it becomes a window and it becomes as problematic. They have better thermal transmission if they are solid and filled with foam or some insulating material. But if they don't, then it's an issue. They're more expensive than windows because they serve different kind of functions. They're supposed to be solid, they're supposed to be rugged because again we go through them unlike a window. So they have again more weight as well. So they are more expensive. Again, what is fenestration? We talked about that. Fenestration is basically a fancy word for doors and windows. So when we talk about fenestration, if you hear that word, you know what it means. Doors and windows. Windows characteristics. There's the glass assembly, the panes, and there's the sash, the frames for the glass, frames surrounding the sash and the window part. And there's also a rough opening that's in the structure, and this is where we have a lot of the issues between the rough opening and the frame. This is the area where nobody pay attention to, and it leaks a lot of air and causes a lot of infiltration. So again, we have three modes of heat loss present. We have convection, that's from the air around the window. We have conduction through the sash and the rough frame, and we also have radiation plus infiltration. So every possible way to lose or gain heat is available in a window. These are the components. Window panes, again, The more panes we have, the more we have area of leak. So this area here is a big area to leak air. The mechanism can leak some air, especially if the window is old. And this is the frame. And the rough opening usually is here. And again, it's a big area for losing and leaking air in and out, and also to conduct heat through the frame and to have radiation through the glass in the window. So this is some glass properties. Okay, let's look a little bit closer. So we have single glass, standard insulated glass, high SHGC, which is solar heat gain coefficient. You'll find that definition later on, so don't worry about that. And VT here is visible transmittance. So that is a good thing, and that's a negative thing. You want more of the visible transmission and less of the solar heat gain. If you notice the R value and the U factor, what are they? This is basically U is 1 over R. So if you divide 1 over 0.9, you get 1.1. They just did the math for you. So this is the best glass ever, which is triple glazed, low emittance insulated coating. And you can see the U factor is very low, and you have very high resistance. This is the best we can do so far. Okay. So who tests windows and who gave us those ratings? There's the National Fenestration Rating Council, NFRC. They do the U factor calculation. There's the American Society for Heating and Refrigeration and Air Conditioning Engineers, ASHRAE, everybody knows them. They do the theoretical framework for calculation for heat flow through the windows, because again, there's a lot of things that goes into it. I don't want to go into it, but there's a lot of calculation involved to give you that nice, beautiful U factor. Another lab that does this testing for windows, simulation development for new windows. And the reason in the project I ask you about the wind is because most windows are rated at a certain level of wind. So the amount of wind does make a difference. So make sure you have the window that's installed within the rating of that wind. American Society for Testing and Material, ASTM, they provide the material for the frames and glass and give you some kind of standards in terms of like shatter, brittleness, ductility, and so on. So how do you read this label? Look at this label. Oh, sorry. So this is some company selling a window. This is the NFRC. This is your U factor. This is your solar heat gain coefficient. Now you know what it means. This is the visibility, and this is the air leakage. So they tell you those ratings for residential, non-residential, and again, it depends on the climate, house, and lifestyle. So those things will be different, and they should tell you how does it work. So this one is double glass argon felt. That's in between the two panes. And once you lose that, once it leaks and once gas goes out, what comes in? Air and humidity, and the window is not good anymore. It has to be changed. And it's also low emittance. Okay. The U factor, how is it calculated? It's 1 over R, we know that. It's combination of all the heat loss around the window. So it's really hard to calculate. Somebody went and tested this over a long time and different kind of atmosphere and temperature and gave you the U factor roughly to be functioning within those limits. So you have to know those limits, which is the temperature, lower bottom, upper bottom, top limit, lower limit and top limit, and also the wind. So convection is from each sides, because again the air will get heated and goes up and circulate again. We have conduction through the window itself, conduction through the frame, and radiation through the pane. So this picture kind of says it all, and how much heat loss we're gaining or losing from that window. More about the heat loss and heat gain. I don't want to go too much into it, but as you can see, it's a lot of issues. Solar and optical characteristics. So solar heat gain accounts for 40% of the total heat gain in the house. That's in the summer times, folks. So when the sun hits the house, there was a lot of radiation coming into the house, and you can see the house being heated, even though it's not leaking in air, and could not be from the wall, it could be just from the windows. So the more windows you have, the more you will have to cool the house in the summertime. So that's something you have to think about. That's again the solar heat gain coefficient, and you can you can kind of reduce that if you have coated windows that will reflect some of the infrared temperature. Shading coefficient. How much does it shade? Do we want? Here's the shading coefficient. Do you want shading? It depends. You can have some tinted glass, but tinted glass also blocks visible light, and you want that visible light in here. So this is clear glass, tinted bronze, reflective bronze, and low emittance. So you want more of this and less of solar heat, which is infrared. And this is the wavelength for visible light. If you look at the spectrum of light, there's infrared and there's ultraviolet. So you don't want the ultraviolet, you don't want the solar heat, but you want the visible light. So far the reflective bronze will block a lot of the visible light, but also give you some solar heat. So the best thing we can make so far is to allow a lot of visible light and reflect the solar heat. So if you look at cars and car tints, if you have those reflective tint films, probably you don't see much, but you don't get a lot of heat. And if you go to drive a car in the south when there's a lot of sun, there's a lot of films been installed built in the glass where you can pass a lot of the visible light and block a lot of the solar heat. Okay, infiltration. It's less important than transmission in new windows because they will be sealed properly. They are leak tested at pressure 25 miles per hour, so we want to know that we do not exceed that amount of wind in that area, otherwise it's not going to work. New windows leak between 0.1 to 0.5 cubic feet per minute, which is not that much, so it's acceptable, given that we learned about air leakage before, and we said we need 15 CFM per person, so it's still not that bad. Most of the infiltration can take place between the window frame and the roof opening. Resistance to condensation. One of the most common consumer problems about windows is condensation. You pay for a window, then in the winter it starts to fog and condensate. That's not something that people want to put up with. So, beside of the complaints about the fog, it's also an issue for the window to deteriorate over time. This will become an issue because the condensation will start to ruin your mechanism. You start to ruin your wood, and over time it also built a lot of junk in the channels. So it's not a good thing to have the window condensating and dripping all over your place. It's a winter problem because outside is going to be dry, inside is moist, and it's cold outside, which means the window is cold, and you start to have fog and condensation. And probably you have that in your car. So think about that. In the winter, you go into your car, the windows start to fog because they're cold. Then you turn on your AC, try to remove the condensation, right? As the car heats up, you heat the windows, so the windows become hot and they do not fog anymore. So if you think about that a little bit, there are two ways to reduce fogging. Either you remove the humidity or you heat the window. Okay, have a nice chart about that. Look at it. So for the NFRC, they rate window concentration between 1 and 100. 1 is good, 100 is bad. So let's look at that. So the relative humidity inside the house, again, we said we want to keep the humidity inside the house between 40 and 60. If we can, otherwise we have to use a dehumidifier. So if the window resistance is between 4 and 2, and this is the outdoor temperature, let's say it was around 20 outside, 10 outside, so 10 and 50 humidity, that's when you start to have condensation. So you want to keep. So if I have a window rating of U equal 0.3 and the temperature is at 10, or the humidity inside the house, let's say at the bottom, which is 40 is here. So I'm gonna be okay until I reach 0. Anything below 0, probably I'm going to have some condensation. So what should I do? Either remove humidity or get a better glass, a thicker glass with more insulation. So the more the resistance, the better it is. So over here we can go all the way up to minus 20 degrees, and humidity of 50%, and we'll be okay. If the humidity above 60, you know something is uncomfortable about that place. So you don't want the humidity to be above 60 at all. That's something wrong with the place. So if you have a swimming pool or a hot tub, probably it's going to be a big cause for humidity in the house, and you need to get a dehumidifier. Window structure, we talked about that. Frame, sash material, could be aluminum, could be wood, could be vinyl, could be fiberglass, could be steel. Right off the bat, you don't want, in New England, you don't want aluminum, you don't want steel, because again, it's going to be very cold, and it will be a lot of conduction through the frame. So probably you see a lot of vinyl, a lot of wood, and some fiberglass as well. That will reduce the conduction. And again, it depends on the temperature difference between inside and outside. Vinyl has issue with UV. For sunny areas, it starts to react with UV and disintegrate little by little over time and lose functions. Aluminum has very high U factor, which is not good. Mechanical operation. So the more mechanism you have in the window, the more problems you're gonna face, because you will have to, over the years, maintain that mechanism, and you will have a problem with sealing. So a window that's more than 10 years old probably has dried up rubbers and sealant that it has to be maintained and redone. This is a interesting word, glassology. Like, what do we know about glass? 3 ways to improve glass R value. Multiple panes, we have up to 3 now. Glass filling, so the more we can get creative with how do we fill that gap between the 2 panes, the better. And how do we keep the gas in there so it doesn't leak? And how do we keep it also in a good pressure so we'll not have a lot of pressure difference between the inside and outside. Inside the pane. So this is the pane, this is where you fill the gas, and you want the pressure to be here equal the pressure in here. Whenever we have high pressure difference, that's when you have leak, because again, we said for us to have air migration, we need the pressure difference and an opening. We can also do special coating from the outside to reflect sunlight. This comes on. Carbon dioxide is one of the options to fill that gap. Argon gas, they have a high R value and high weight, so they maintain their location and they do not leak as fast. We can also improve the glass spacers. So when you see a lot of small little panes, it's just to insulate the glass and have some structural support for the 2 panes not to collapse on each other. Windows films are very popular. Again, they go from the outside or sometimes from the inside to reflect the heat. Shades and blinds and shutters are really great options for us to counteract the heat loss through the window. Shades are good in the summertime, and in the winter they're also good because they provide a barrier between the glass and the space. So shades and curtains are very good for both seasons, summer and winter. Blinds as well. Shutters are the best options because some of them they completely shut down the window from the outside and provide a space that will act as a barrier between the outside and the inside. Here are some of the weather stripping options that you can put in the window when in the moving parts. Foam tape, felt. The V seals are very important because it clasps against whatever is on top of it, so it will give you some kind of flexibility to press against the window. Springs and also V V-shaped silicon bulb. Silicon has become very common because it has good sealing ability and it does not react as much with UV. I think also if you go through the book, there is a lot of information about windows as well, so make sure you check that out. For doors, let's look at doors. What do we have? Solid doors resistance. If you look at the book, there are various variable types of books of doors in the book, and probably that around page. If you look at the H22, between page 71 and 75, you will find a lot of types of doors, and they'll give you the U factors and the R value. And if it's not there, you can always look it up based on the book, based on the type of the door. And also, it's good to look whenever you purchase the door to ask about what is the R value and the U factor. And now you know what that means and how would it affect your heat transmission. So insulated door panels, usually you get the R value, and you can find from the R value the U from the R value. So in this case, there'll be 1/5 for the U value. Storm doors. What are storm doors? Let me take that out here. So storm doors are really great idea, because what they do is they kind of provide segregation between the main door and the second door. They increase the R value and reduce the infiltration, and especially if you have some kind of a corridor, you want the first door to just isolate a small area where you have an air exchange. So it's, instead of letting air inside the house that is 0 degree, you don't let the entire amount of air inside. You just trap it in the hallway or between the storm door and the regular door. So that's a really good idea. And think about it also, if you cool your house and you open the door, all the cold air from the house will just drain to the outside. So you're losing a lot of air. And if you have a thermal camera to look at that, it will be like a flood, an avalanche of hot air or cold air moving from inside or outside the house. So storm doors do a really good service to reduce the heat loss from the house and the heat gain from outside the house and inside. Again, same types of weather stripping. Doors again have a lot of openings, and it's good to weather strip the door and have something to counteract the pressure from inside to outside. And probably now you think about having double doors, right? Or having a storm door to kind of reduce the amount of air coming inside the house due to wind. Okay, that's all the information I have in the PowerPoint about doors and windows. The book has a lot of information. Please browse through it. It's very useful. And for the project, you will see I have selected some type of windows and doors, but if you want to change that, you can look through the book and give me other suggestions. Okay, I will post some materials on Blackboard. Please watch the video and look at the references in Blackboard. Thank you.